Good morning. People are joining, that's good. We start around 10 probably. Need to test the stream because it's first time streaming here. I'm just checking if all the chats are working. I hope the audio is working as well. But for me it looks good. Perfect. So two more minutes to grab yourself a coffee and then we get started. That's good. We have people on all streaming platforms. They're on YouTube, Twitch, and LinkedIn. I need to check. Looks also good. Nice. Well, seems to be working. All right, let's get started. Let me head over to the Medium article, because today we are implementing, but we are also writing an article on the side. So we're doing both today. I think it's quite nice. Let us go to the article. And today we are talking about how you can orchestrate generative AI applications. But it's not only related to GenAI, you could also use it to orchestrate any kind of application you might have, or business logic, or whatever you want to in somehow orchestrate. We are using cloud workflows for that. It's a Google offering which helps us to build those orchestration steps or orchestration pipelines. So you can have multiple steps, and each step in those pipelines can do something. And there are pre-built services which we can just simply integrate, but we can also call API endpoints, which we can host ourselves. And we see what we need today. I haven't started yet. I just did some brainstorming yesterday and put together some more ideas what I want to build today. And we're gonna go over this now. I just need to reduce the noise a bit, the audio. Yeah, seems better now. All right, so the plan is to use Gemini, or Google's multimodal model, to generate a recipe, and we also want to use Imagine to generate the recipe image. And somehow we want to combine this together, right? And what you can do on your local machine, you could just build one Python file or one Node.js file, JavaScript file, and it's doing everything. But if you're on a business side, you usually have business processes, business pipelines, and they usually involve multiple steps. And it's nice to orchestrate this in a more nice way and go away from this monolithic applications. Even it's quite small, it's still monolithic, right? Because you have a lot of stuff in one Python file and it's doing all the same. We actually want to orchestrate this with proper tools. And it gives us also the flexibility to do proper retries. We can have multiple steps running in parallel. We can loop over multiple steps. You will see how this works probably today already. And in addition, I also want to use the control generation, which is supported by Gemini. So that allows us to get a valid JSON as a response all the time from the Gemini model. This helps us to directly use the output from the Gemini model as input for our maybe next step or store the data somewhere. Later on, probably not today, I also want to put a human into the loop. So for all the recipes generated, I want to have one step in the orchestration pipeline where we have a human needs to approve the recipe, because probably already heard about the story where Google recommended people to eat stones. We want to avoid this in our recipes. So we just make sure one human in the loop can review that. And maybe we also send out email notifications to a group of people who can review the recipes. Maybe we need Cloud Run. Let's see. I said there are pre-built services which we can integrate with Cloud Workflows. Also Gemini is supported. I haven't tried Imagine yet. Maybe it's there, maybe not. Let's see how it works. And maybe we need to or can build our own Cloud Run service which can be integrated in Cloud Workflows. In all this recipe, the recipe itself and also the recipe images, I want to store on Cloud Workflows. And I see more people joined. Morning, Lucas. Good to see you here. So let's take the simple use case. First thing we do, we generate a GitHub repository. Let's call this Generative AI Orchestration. Let's do this. I use Python. README. Larger for you. All right, let's take this. Quickly open this here. 1 second. All right, and first I set up the environment. I just need to blur this for a second because I want to add the project to the workspace. So here we have it. All right. So we have generative AI orchestration here. It's now obviously empty, but we will add here content soon. Before we actually dig deeper into the code, let us go back to the documentation for that. Always start with the documentation. It's always a good idea, I guess. Let us go here. So workflows overview. Here's a nice example. I saw this today in the morning, where you have basically you upload a file to a cloud storage bucket, and the cloud function triggers the workflow. You can trigger workflows in different ways, pops up via API calls. You can trigger them manually. You can schedule them, so however you want to build your process. And then in this case, it checks what kind of file it is. It's a TXT, is it a video, or is it an image? And then it's doing different stuff. And each of those steps is one step of the workflow. And then it takes all the data and stores it in Firestore. And you can see the different steps call different APIs. We do something similar today. We're going to call Gemini. We're going to call the Imagine if it's possible. And then we store everything on a Google Cloud Storage bucket. Here are a few use cases. Yeah, they're actually quite nice. So you see we can use it for service orchestration. You can also run batch jobs with it. Business processes, I think that's where it's actually coming from. A lot of companies use this for business processes. And also IT process automation. Yeah, you could trigger provision new tenant projects. You could also use Terraform for that. All right, sounds good. Let us start with deploying a workflow. Let's go to the G Cloud example. I'm not going to use Terraform today. First thing we need to check. So this is how you can build your workflows. You can use YAML and also JSON to build those workflows. And you see we have multiple steps. Each step is doing something. In this case, we're having some input, getting some location, and calling some Wikipedia stuff. I'm not going to use this example now. We're going to look for Gemini example now, and then we give this a try. Good to know. We need to deploy the workflows with gcloud workflows deploy, give it a name and the workflow file. In our case, probably we use YAML, I guess. Makes sense. And after that, we can run the workflows. So let's see if we can find something for Gemini. Okay, we can also delete it. Makes sense. On the left side, let's see, we have the documentation here. What do we have here? Looks good. Here are examples. Let us go there. That's the overview page. All right, let's go back. Syntax overview. Okay. So we have the syntax here. We can actually search the syntax. So we have a main workflow, and then we have steps. And there are control flows, so we can call, jump, have conditions, iterations, parallel steps. That's actually pretty nice. We probably use this later. Variables, runtime arguments. Gonna probably use this as well, because if we want to create a recipe, we need to somehow be able to have a prompt, or if we want to generate a breakfast, or we want to generate a dinner, we can have this as a runtime argument. All right, and we also have retries and errors and catch errors. It looks quite good. First thing, we need to find out how we can use Gemini. I know there are connectors available. So basically you have connectors where you can integrate into already existing products on Google Cloud directly with the workflow YAML or with the workflow JSON. And let's have a look into AI platform. And now we need to find the point where we can call the Gemini model on the left side. It's a lot here. Oh, I think it's under, at least under endpoints, because it's an endpoint, right? So we have create, delete, deploy, generate content. That's probably what we need. Stream, generate content. So we're going to we're not streaming, we're just generating. Let's see if this is Gemini here. So we're providing the model. Region body. Let's check the body. What do we have in the body here? All right, this looks like Gemini. So we have contents, which is our prompt. We have safety settings, system instructions, and also tools are also supported. Nice. All right, scroll down. All right, here we have a snippet. There's one for vision. Describe this picture. So we have the prompt here. Don't need vision. We just take the normal Gemini. All right, let's take this. Give this a try. We saw how we can actually deploy it and run it. So go here, call this recipe.yaml. So what is it complaining here? Incorrect type. Correct type for what? I'm not allowed to call this recipe. Why? First struggle, always good. Let's see what's happening here. Let's take this out. Correct type. I see. So it's not the full code in the documentation. We actually need to, let's go back and check the documentation again, right? Always good to go to documentation. So it seems to be missing something because we just have one step that we just saw in the syntax. So if we go If we go back to the syntax, let me open this in a separate tab. Let's go back to the syntax. All right. We probably need a main as well. This is part of the syntax here. Yeah, so we have main and then we have steps, and then we actually have the steps. Let's take this. Let's go back to Visual Studio. And from there we're gonna, sorry. From there we're gonna take everything here and move it like that. Unexpected property main. Let's check the documentation again. Main looks good. Let's do it differently. Take this way. Unexpected property main. Don't need params. Check them out. Feel free to suggest if you have ideas. But for me, it looks correct, right? Let's go here again to the syntax. So. Main steps. Let us check again the example we just saw before. Is there a simple example? Is there some kind of hello world? No. Let's take this one. It's also missing the main, right? Something seems to be off here. Main steps. And then we have the steps. All right, let's give this a try. Maybe this works. So what was, let's deploy again. Maybe this is just in my editor. So we go back. So deploy, let's scroll down. Maybe we actually can take this example. Let's give this a try if this is also running into the same error. Yeah, probably some something which is not related to, which is related to my IDE. Okay. All right, let's give this a try first here. So we take this and take a source file. Source file is recipe.yaml. It's now doing something differently, but I think that's fine. All right, so it's working. Let me check. Probably it's one of the YAML extensions. For some reason, let me disable this. I need to reload. That's fine. All right. Let's ignore this for now. But it seems to be working. Let us also run this workflow. So we just deployed it, called it. I need a search term. All right. As I said, the typical struggle we have. So a search term, what do we want to search for? Let's search for Google. And it was called recipe. Call it recipe. No, we called it my first workflow. All right. Invalid character. What does the input need to look like? Needs a search term. All right. Let us check that. We have an input, which is an array. All right, makes sense. And then we have conditions. We have inputs. So, okay. We need to structure the data in a more structured way. Still, isn't the example working here? I need that. This looks better now. All right. Got it. So we need to put it into quotation marks. All right, and now on. Let's see how this looks like in Google Cloud. And then we can go back to the Gemini example. Let me blur this for a second here, because I don't know what is open. All right, let's go to workflows. Here we have the workflow we just created. Can go here, have a look what it has actually done. So it has, zoom out a bit, it has multiple steps. So it's first checking something, and then it's searching, and then we're getting search results back, probably. So we search for North, so we're getting North America, North Korea, North Ireland, Northern Cyprus. All right, that's working. Let's go back to our Gemini example. Go to the connector reference again, Google APIs, was AI platform version 1, and then we checked for endpoints. And here we have generate content. So let's take the example from here. Ignore the IDE error here, because it's probably something else. And we're adding the steps here. Delete that, edit. So it's translating from good morning from English to French. Yeah, from English to French. And it's not generating a recipe either. We probably need to redeploy that, but now we are renaming it. Actually renaming that recipe. And let's run it. We don't have any. We have an input. Let's see what we have as input. It's not used. It was from before, right? Okay, well, we can keep it empty. Don't need the input here for now. And it's called recipe, but it's doing a translation example. I think that's fine. Right, just deployed. It's on it run. All right. So we're having some error here. Let's see, permission denied. Project ID. So project ID is not defined. Probably could add some variables to it. Do we have it here in the example? No. So we workflow syntax. Just open this in a different tab. Let's see. So we have variables. Give this a try. I see my camera is stuck, right? We changed it. Seems to be working again. All right, let's see how variables are actually working. Probably it's this a sign here. Looks good. So we call it init assign, and then we give it a name, and then a variable. All right, let's give this a try. Was it part of the step? It was part of the steps, right? Oh. Init. Assign. We also need to check if we can actually get this out automatically. But for now, we can do it like this. Let's actually do it way easier. When we dig into this deeper, let's do it like this, and let's check later on how we can automatically get this out, because we're running it inside of Google Cloud, so there needs to be a way to get this out automatically. So let's start our playground. Do it. Give this a try just to see if it's working again. Let's run it. So succeeded. Nice. We're also getting the result directly here. Let's anyway check it here. Our workflows tab. Let's go back. There should be another workflow. So we have recipe now. The one failed before, and this one just succeeded one. All right. So we had hello as input, and now we're getting bonjour as output. Just can have one call, just Gemini, and just do translation, and then we have a return step. Where's the return step actually? So it's here. So we are returning the stuff from the Gemini model. All right. Let's generate a recipe. So we do it very easily. Generate a recipe, breakfast recipe, like this. The rest we keep for now. It's probably anyway working. So I think about we maybe could now add already the pop-up JSON response. So I could now tell the model, please return a JSON in the following format. But that's always a little bit tricky, because not all the time it's actually working. Sometimes you're not getting the proper JSON. Sometimes there's some text before or after the JSON. You need to pass it. But because of that, Google introduced control generations. So we're going to use this here as well if it is supported. I hope so, because it's anyway just calling the API. So it should be supported. Let's remove this here. So we only telling the model it should be generate a recipe. Probably use the system prompt later, but now we do it like this. Let me go back to Medium. Open up the article I wrote a couple of days ago. Control generations. And go to the notebook. You see, for control generations, we have two additional parameters. One is called response MIME type, and one is called response schema. We can actually give this a try if this is already working. So we go back to the code and check if this is working or not. So let me go to Visual Studio. It's part of the generation config, so we can just add the response MIME type to JSON in our case, right? Because we want to use JSON. JSON is the only one which is supported. This is probably wrong. To do it like this. And then we have application.json. Yeah, like this. You can check all the different supported MIME types when they release it. At the moment, I think it's only JSON. There's XML, HTML, and other stuff in preview, and you can also have a custom objects later on. But for now, it's only JSON. Let's give this a try, but we need to change the model because Gemini Pro is, as far as I know, not supporting it. So let's go to Vertex AI. Grab the latest Gemini 1.5 Pro version. Let's see what we have. To Vertex AI languages, text prompt. Taking the Pro. So Gemini 1.5 Pro. Let's take this one. That's probably the Flash, and this one is the only one supporting generated content. And let's see if we're now getting a JSON back. Let's run this again. Looks quite good. So we're getting a result, which now looks like a JSON. What do we have here? We have a name, recipe name, we have ingredients. What else do we have? Hopefully a description somehow, a quantity for the ingredients. Right, looks not too bad. But now this could be, every time we now generating recipe, this might be look differently. So we need to tell the model how this should look like, and for that we can use the response schema. So if you go back to the control generations, we can have a response schema. Looks like this, where we actually define how the recipe looks like. I did this before for the other article, but we can take this and give this a try. You see we have response MIME type, so we're now adding response schema also to the workflow YAML, response schema. And this one is JSON. So we are taking this, and we need to transform this into YAML. Let's use ChatGPT for that. See if it gets it right. Looks quite okay. Maybe use an array here. Okay, let's see if this is working. So we have the schema, and this schema, yeah, since it's just YAML, we could just simply add it here. So we have properties. The properties which are on the same level like the type object, but we need to an indentation to the right. See if this is working. Let's deploy again. The good thing, the deployments are really quick, so it doesn't require a lot of time. So it doesn't complain during deployment. I'm not quite sure if they're actually checking something during deployment. So let's run it. Looks good. We're now getting a recipe description, exactly how we defined it. There should be also recipe title. Let me see if I can find this. Recipe title we also have. We have the ingredients, exactly as defined, with the name and the quantity. with name and quantity and the unit of measure. Unit we also have. All right. So it seems to be following our schema structure, and now we are getting always a valid JSON which is following exactly the structure. Looks quite good. So this is our first part of the pipeline, of the orchestration pipeline. So if we go back to recipe, you see we call just Gemini, right? Next step, probably makes sense to store the recipes somewhere, because maybe you want to show this on a website, or you want to do something with the data like you usually do with business processes. So I want to persist this somewhere. And for that, we could store it to cloud storage. There are those connector references. And we have the Google APIs. So we could check for cloud storage, probably called storage. Let's check the documentation. All right. Cloud storage JSON connector. So there is something already there. So we can just simply call this one to, no, we don't want to create a bucket. We want to upload the object media. All right. That's a good point. Let's create a bucket first, or let's see if I have already one which we can use. Let me blur for a second again. Go to cloud storage. I have one bucket which is called do.it-llm. I'm going to create a folder called recipes. And let's check the recipes. Where's the recipes folder? So, all right. Now we have a bucket which is called do.it-llm, and we have a recipes folder. Okay, let's take this. Go back to the example. We take this one and first give this a try without actually storing something. So before the return step, we call this one. We insert into a bucket name. Let's also make this hard-coded for now. Do.it-llm. And then into recipes. So we also have an object name. Let's do it. Let's call this. Because we need to define the path. So it's recipes test.txt. Let's see if this is working. Not storing any recipe yet. Just want to see if it's actually creating the file. So there's an error. Expected a mapping. Upload media. Object. Expected a mapping. Let's see what we get here. But no. So we have upload, and we have the call. The upload, and we have the call. I see. Wonderful word of YAML. Probably need to enable the parser again. Oh, I need to deploy. All right, I did something. At least no error. Let's go to the bucket. Let's refresh. See if we have something in the recipe folder here. There's nothing. Let me see if it maybe creates it a level up. Right, it created this one here with the backslash. So I probably can just simply remove the backslash here. And then it should be in the correct folder. We go back again. Let's run it. Right, I see I need to take more attention to the chat here. You wrote salt, egg, and toast. It's a wonderful breakfast, right? What else do you need? All right, let's reload. Did it actually run? It did something, but nothing in the recipe folder. Let me blur it again. Go back again, check. Let me delete the previous folder here. Delete. It's called recipe. You see, it's important. The small details are important. So now we're gonna have it. We go to recipes. There we have it. So it's now having a test.txt. Let us download this. It's downloading, and we have hello world in this file. All right. Next step. As a next step, we need to store the JSON which we're getting back from the Gemini model and store it as part of the step where we're uploading it to Google Cloud Storage. And for that, we somehow need to parse the JSON, because you might saw the JSON has the wrong encoding here. It's probably, we cannot simply take it and save it, because then we have an invalid JSON. So we need to parse it properly. We need to check if we have a parser. And I also want to have the file name with some kind of automatically generated ID. Or maybe we want to generate recipes. Every hour we want to generate a recipe, or once a day. And for that, we need to have some kind of unique identifier. And I know there are some system packages which we can use. Let's check them. It's called standard libraries. All right. So we have JSON, decode, encode, and so base 64. Maybe we need this later for Imagine when we're working with the images. And we also have UUID. So let's check how this works. All right, we're just doing this and calling the generate function. Don't need to import anything. That's wonderful. So let's adapt this a bit. So we have this one called recipes. We have the UUID, and then we want to store it as a JSON later, right? But now it's a TXT, so for now we call this TXT. Later on we change it to JSON, but first we need to actually want to have this as a parsed one. Let's give this a try. That's quite nice with those system packages. Or how was it called? It was called standard libraries. Really like that. Let's go. Even math here. Not a lot. I wonder why just those, but it's not bad. And here also we have the retries. We check this later. All right. Let's deploy it. Oh, we deployed already. I need to somehow have this chat as an overlay here on my Visual Studio Code. Otherwise, I actually missed the chat conversation here. Mohammed was actually asking what we're building here. So we are building a GenAI application, but one which is actually orchestrated. So I have multiple steps. The first one generates a recipe, and then the second step generates the recipe image. We upload everything to Google Cloud Storage, the image and the recipe itself. And we also want to have a human into the loop to actually approve those recipes. And then later on, maybe we put this on a website or something like that. So we are orchestrating multiple calls to different APIs, and for that we're using cloud workflows. All right, at run, we now should have a file here in the recipes with the UUID. Looks good. That's what we need. Maybe later on we incorporate also the recipe name here. Let's see if that makes sense. That is actually needed. Probably it's not needed because we can just use it from the JSON itself. All right. Next one. We are going to do the JSON parsing. So we go to JSON. So we have decode and encode. We need decode because we want to decode it. This is how it works. All right. Simply returning. We have an output message. All right. Just one. They have it as one additional step. Yeah, we can actually also do that. Have the parsing as an additional step. And if something fails with the parsing, we could actually properly log the error as well. But for now, we keep it like that. So let's do this. What's JSON decode? Oh, sorry, the window is gone. JSON decode, and then all right. So be done before we upload. So we call this how do we call it? Call this maybe parse JSON recipe. Need to get used to those double indentations here. And here we need to parse JSON recipe. Need to assign a variable. Let me check the documentation for that. And I just output it here. But we want to use the variable because we want to use it in the next step. So we go to the syntax again. I always close the syntax. That's fine. Let's open this one and check the syntax again. Variables. So that's what we already wanted to use before. So now it's time to use it actually. Go back. We go to the thing to assign, and we call this. How do we want to call this? Parse recipe. And from there, we now need to actually do the decoding, which we just saw. So we go back to the. Where is it open? Here, decode. So we're going take the take exactly this one here. JSON decode. This looks good, but we are not having base 46. We are now exactly using what we had before, and this is here at the bottom, right? So we're taking what we returned before and putting it inside of Opala. Sorry. So we're taking this, taking that from the bottom. This is where we actually get our JSON from the Gemini model. So we are now calling JSON decode, getting the Gemini candidates and parse it in parsed recipe. This should actually work. Check the documentation again. JSON decode. We assign it into a variable because we want to use it. All right. Next one, we want to upload this as part of our, now it's not txt anymore, we want to have a proper JSON. We have JSON here, it's still media, which we upload here. This comment, it's useless. And as body, we now need to encode again, right? Because we decoded the escape JSON, and now we need to encode again. Because we want to have it back as a proper JSON. Let's check the encode. Here we have it, JSON encode. All right. This is always the syntax if you want to access and do something. So we have this, we call JSON encode. JSON encode. And now we are taking the variable from the step before, which was called past recipe. I wonder if we need to return this. But we assign it. It should be enough. No need to return something. All right, let's give this a try. Nothing failed here. Does someone know if there's actually validation done during the deployment? Or is it just taking what is there? Oh, my camera froze again. Thanks, Evgeny. I need to check this, what's happening. Maybe it's too hot here. I'm under the roof. Let me change the camera again. Maybe it's also OBS. Gonna check this for the next stream. All right. Does someone know if deployment is doing some validation for the YAML, if it makes sense or not? We can add an error and actually test this. Let's run it and see what's happening. So no error, that's good. It succeeded. Let us go to the bucket. Interesting things first. So the last one was 714. And let us refresh that. Now we have 777. Lucky number, nice. Download this and actually have a look into the JSON. If we have content there or not. So let me open this in Visual Studio. All right, cool. So it's stored on cloud storage. So we have a now multi-step process already. Let me check. This looks like a valid JSON for me. Everything in one line, but that's fine. Let me format this. All right, looks good. Seems to be working. Cool. Let us also check the workflow. And now we see how the workflow looks like. So we now have already a multi-step process. The first one is calling Gemini. The second one is passing the recipe. We could add some error handling here maybe later on. We upload the recipe to cloud storage. Actually, I don't like the step name. We should change this. And then we have the return step. And the return step is still returning the recipe for now. I think that's quite nice for debugging here. We could keep that. We could actually, if we have more steps, if we're later on generating the image, we could also have this as a return step, and then we're getting as end step or as end output of our pipeline, we're getting the recipe image, and all the information we might need. Sounds good. But let's go back to the recipe workflow, and let's rename this because we are uploading recipe to Google Cloud Storage. Makes just more sense. I understand exactly what this step is doing. All right, that's nice. So we used the available libraries like JSON encode, decode. We generate the ID, unique identifier for all the recipes because we want to generate more. We also do decoding. We upload everything. We use control generations, which makes us always a valid JSON in a specific format. And we're having our prompt. I remember we wanted to have this as a parameter because now it's generic. We want to generate different recipes. So we had this already from the example before. It's called params input, but let's check the syntax again. I'm not guessing, always checking the syntax. So it's a runtime argument, because we want to provide this during runtime. So it's called just params, and then we have an arg name. And to use it, we use the $ arg name parameter name. All right, that's probably something we can do. Where is it here? So we have, it's called input. All right, we can keep it as input. Why not? So arg name, call this input, and then we have call this recipe prompt. Like this. And there was this example how to use this, right? So we need to add this as a data when we're actually calling the workflow. Yeah, passing in the arguments. All right. Someone remember the syntax from it's first deploy the recipe again. Then one recipe, and then we had minus data, right? Was it correct? And here we don't have first name, last name. We have four recipes. I'm gonna generate a barbecue recipe. And we also need to rename this. This is called the I forgot it already. We called it recipe prompt. Let's see if this is working. Was it minus data? Same error like before. I need to put this into those quotation marks. Obviously. Unmicronized arguments. We need to just see single quotes. All right, we need to remember that. So we need to use single quotes here, no double quotes. Yeah, it's like always with this with G-Cloud, right? Makes sense. All right, we're getting a new recipe. Some slow cooked ribs. Fall of the bone sounds good for the non-vegetarian people. Let's actually do generate a vegan barbecue. Let's see how Gemini is capable of that. That's nice with the prompt. Looks a little bit more complex than before. More ingredients for sure. All right, this looks good. So we have the parameter. And I think that's all we need for generating the recipe. We have half an hour left for the stream. Maybe we can get started and actually trying to test the Imagine API. But for that, I want to also add a prompt here. So I want to have our Gemini module generating the prompt for the image. So I don't need to take care of this myself. But before we do that, I want to quickly show you how Imagine looks like. And it's working. So Imagine is the image generation model made by Google. And we can go there and we go to Vision. And here we have the Imagine model where we can generate images. You see we have different aspect ratios. So we could use, probably if you want to put it on a website, it's 16:9. If you want to put it on social media, it's probably one of these formats here. Let's take the 16:9 because I like it if it's on a website maybe later on. And let's generate, let's see if we can do a hot dog. Nothing too complicated yet. Let's do a hot dog for now. All right, this is working. We get actually a couple of hot dogs here. I think we can set this parameter number of results. Okay, later on we just probably generate one. Maybe we could also generate 4 and have this as part of the human review process, and they can select the best image. Actually, I like that. No, this looks good. Yeah, we keep it with 4. We probably store all of the 4 images together. And then later on, when we implement the human in the loop feedback, human in the loop process, then we can have one person approving. Yeah, I like that idea. That's a good one. All right, before we use this one as part of our workflow, I actually want to first give this a try, actually see how the code looks like for that. So let's go to Google Cloud Imagine API. Let's see how the API looks like. Not quite what I was looking for. Imagine on Vertex AI. This looks like the correct documentation. This is the overview. We want to create images, so it's limited access. So it's not private preview, but it's publicly accessible, but only if you're whitelisted. So if you want to use this, you need to request access for it. So we're generating images using text prompts. There are different versions. Oh, this is the newest version. It's probably also what we used here, right? Yeah. Zooming and making the image smaller. All right. So we have 0.06, right? Per minute. So we're not reaching this quota. Maximum 4 we can return per request. Maximum image size upload or send in a request. No, we don't want to upload images. And here we have the aspect ratios. With the resolution. All right. So 16 by 9. That's not too bad. That's actually way enough, way more than we need for actually a website. Now we have people asking what I'm demonstrating here in the chat. So we are building a generative AI application where we're creating a recipe as a JSON and also recipe image, store everything on Google Cloud Storage, maybe later on have a human into the loop who needs to approve those automatically generated images. And we are using cloud workflows to orchestrate the whole process, right? You could build just one Python file doing everything, but I like this cloud workflows idea where you have multiple steps and you see how this is actually working. Someone was asking in the chat here. Let's see if we have code here. Generate images with text. No, we don't want to generate images with text. I just want to generate images. All right, let's do it with text. I mean with text as input. All right, got it. So let's have a look into the REST API. So we're calling an API. We need to see if this is already supported as one of those pre-built connectors or not. Haven't seen it in the endpoint before, but let's check that. And yeah, we simply have our prompt and we have our parameters. And sample count is the number of images we want to get back. Now, usage seems to be quite easy. Let's also check the Python code. I'm a big Python fan. All right, so we have also aspect ratio, the safety filter, person generation. What is this doing? Allow adult. If you want to allow humans on the images, probably. We can have watermarks. That's actually a nice feature. If you generate those images, you can watermark them. And later on, if you put them on your website and someone is stealing your recipes, you can actually check if this is actually one of your images because they are watermarked. But it seems to be only working if you're not using a seed. So you can use a seed value and a watermark at the same time. I wanted to use seeds to have the images looking very similar. And I wanted to use watermarks, but there seems to be a limitation here. Let's see if we actually need a seed or not. It's also interesting to know how big those images are. All right, so we're not going to use Python for now. We want to use the existing endpoints if it's existing. I quickly checked yesterday and I couldn't find anything, but I want to give it another try today to make sure I didn't miss anything. I would assume it would be also under endpoints because we have everything else here, right? We have generate content, we have stream content, we have, if we want to predict with custom models we have here, but there's nothing Imagine related. Maybe because it's still in preview and they haven't published it yet, or it's under beta here. I haven't checked beta yesterday. See if we can find something. And if not, I have an alternative idea. Location endpoints. You see, it's the same like just with beta. Do we have Imagine here? We have count tokens. Create, explain, but also no Imagine. Predict, raw predict. That's also nice. We could actually add additional step in our pipeline which is counting the tokens, but you get it as a response from the Gemini model anyway. We could log this. Would be actually quite interesting to see how many tokens we used. Add this to the to-do list. So there's no Imagine. I assume probably because it's not yet publicly released. It's still under those whitelisting. They maybe haven't added it yet. Or there's something I don't know of. Or it's listed somewhere else, but why should they have everything here under endpoints except for Imagine? Could be. Let me search for it. Imagine. No, there's nothing in the search as well. Let me quickly do a Imagine Google Cloud Workflows. No, that's not what we're looking for. We have connectors here. There was the AI plug. No, where is it? Vertex AI, Vertex AI. Let's see if we have in the connector something here. Well, it's just one example, right? And if we go to the connector overview, because Imagine is part of the Vertex AI connector. Now we're on the overview page. Oh, that's nice. We can search for. Do we find Gemini here? No, we just find generate probably. Generate content. We have here generate images. No. Imagine. No. So I guess it's probably not yet supported, but we could use. I know you can also call HTTP endpoints with Cloud Workflows, and we are having this API endpoint, right? So Google is all API based, so we could use the REST endpoint, which we have here, and simply call it like this. Input is easy. We just need to check how we can pass the response, but it's probably, maybe it's base 64 encoded, or we're getting bytes back, something like that. Actually, can we see that from the code which we saw before? Let's give this a try. Here's the response. Yeah, makes sense. Just scroll down and then we get the response. So we're getting the MIME type. It's actually called predictions. That's interesting. What? I saw this prediction endpoint. Predict. Let's see what this is. Why do they call it predictions if it's an image? Kind of weird. The name of the endpoint. Could this be used with Imagine? Endpoints predict. But how do we define the we have the body, right? And we have the endpoint. So maybe this could work. We have an endpoint, which is an URL. We have the body, and we're getting the predictions back. Let's use the HTTP general functionality of workflows. So let's ignore this. Maybe this could be a good point. I want to add this to my article to give this a try. I wanted to write an article today, but I'm really into the coding mood for now. So let's first figure things out, and then we can work a little bit on the article as well. First, want to generate the image as well. So we're not using this now. I want to add this here to the documentation as well. Maybe I need this later. All right. Let's use it with an HTTP method. So if we go to back to the Cloud Workflows stuff, we have the syntax, client libraries, connector reference. It's all for the HTTP stuff, for the Google APIs. Let's check this. Cloud Workflows, HTTP call. It's always called call. Make an HTTP request. That's what we want to use now for Imagine, for now at least. So we're having a step name, we have a call, which is called HTTP request, and we have different methods. All right, so we probably want to have it, it's a get or a post. It's a post. We want to send it data, so we have a post. We have our URL. Why is it duplicated? Twice. Required if using call type HTTP request. Yeah, but we already have HTTP put here. All right, let's see. I also have a header. We need to see if we need to do something with authentication. Is there something? Use OSIT to authenticate when making requests to OIDC. Do we also have OAuth? OAuth. All right. So we have the out type. Since we're calling from Google Cloud Workflows to the Imagine API, it's Google to Google. So we could use simply OAuth because they're already authenticated, I guess. Keep this in mind. We tried without any authentication first, see how it's behaving, and then we can try OAuth. This should work. Not sure about this one because here we need to provide a token, I guess. But this should work without anything. All right. And then we can define a body. This is where we need to define the prompt for our image and the number of images we want to get back. All right. Invoke an HTTP endpoint. So call HTTP request, args, and in args we have just the rest of the stuff. All right. So we call that steps. Do we need to assign any kind of variables? Maybe it's a good time to use the variables because we want to maybe use different model versions of Imagine. All right, let's do it without for now. So let's go back to the code. We do this as a dedicated file for now. So we have the recipe. Let's don't do this as part of this workflow step. At least during testing, later on we integrate this because we want to have one big workflow. But for testing, it's now easier if I can just focus on the image generation. So we call this recipe image, not YAML. And then we have the main again. And after main, do we need parameters? The prompt, right? We need to have the prompt again. And let's do it hard-coded for now, we're just testing. And here we want to have a step, which is called generate recipe, image twice, and then it was call, what was it call? And then we had HTTP post like this. Let me check again. Call HTTP post, call, and then it was HTTP. Yeah, we're doing post, so HTTP post. And after the call, we need to have the next step are our where's the URL actually? It should be part of the args, right? Yeah, so we have args and URL. Take this. We have args and URL. And in URL, we're now taking the Gemini API, the Imagine API, sorry. So it was here, where was it? Yeah, so let's take this one. And for now, we simply copy paste this. So we have the variables again. As I said, I check this later. I want to focus now on the variable stuff. So we have Dasha. Do it. Location. Let's do this in US Central 1. We have more variables here. Another location. And we also have the model version. And we just saw the model version was 006. So it's called image generation. And then we have an add, and then we define the version name 006. Is it actually defined the model versions here somehow? Model version. Oh, we have it here. That's nice. Let's copy paste this in case I have any kind of typos here. Do we need more? Yeah, we need more, right? We want to have the response. We want to see what we're actually getting back. So previously we did this with result. Let me check with the recipe again. So we had We had it with return. We start here. We had the Gemini response. So we are doing the same now. We store everything in a result and we call this the generated image. And you realize the error from before is gone. That's interesting. I wonder what happened there. All right, let us deploy it again. Now it's called, call this recipe image and also give the workflow different name, recipe image. It's actually quite nice. You can call any kind of API this way, right? I got an error. Obviously, we need steps. Steps, always the same issues. So let's take this one. Now, what I want to say is actually quite nice. You can call any kind of HTTP endpoint. So we could also have Cloud Run services. You could call external APIs. That's actually quite nice. And now we run it. Run, and we call what's called recipe image. Let's see what we get there. So what do we have? First path segment URL cannot contain colon. I see. That was a typo. Let's deploy again. So we're getting an error. As expected, we need to do authentication. So it's expecting an OAuth access token. As I said, usually if you're inside of Google Cloud and you're calling from one cloud service to another, you don't need to take care of this authentication yourself because they are already authenticated if the services are allowed to call each other. So it should be enough to add the add authentication as part of the call. So let's go back to that. What is it here? No, it was predict. Runtime arguments. I have too many tabs open. Let's close a few of them. Search the syntax. So here. So we had out, and it was just out type. So we're taking out type. It was part of the args exactly. Let's do this here after the URL. Out type, and then we have out. Typing is correct. Let me check that again. Out to, yeah. So it's deployed. Let's run it again. Yeah, makes sense. So we're getting an error empty instance because we don't have any prompt yet defined, but it seems like we can do successfully authenticate against the Imagine API. Looks good. So let's add the body. Body we have here. So let me scroll to the top. Body is on the same level like the auth. So let's do it before we do the. Actually, I like it if we do that after the authentication, after we write what we're actually authenticating. So we're having the body, and it's expecting instances. So we have to have instances as part of our body, and the instances could be multiple prompts. So we have prompt. Let me check the documentation again. Instances, exact. So we can have multiple instances. It's just an array, and then we have prompt, and then we're getting the text prompt. So we have prompt, and then we generate a hot dog. Do we need anything else? We could define the parameters. Let's take the default ones. I think the default one is 4, which we want to have. Maybe it's also 1, I don't know. Let's give this a try. We're getting something back. So it failed. Let's see what actually happened. Actually, the response exceeded the limit of, what is it? 1, 2, 3, 4, 5. A little bit more than a limit of 2 megabytes. So it's 2 megabyte limit for the HTTP response. Which HTTP response? The Cloud Workflows limitation. HTTP response exceeded the limit of. All right, seems we have some limitation here with Cloud Workflows. And this is stuff which usually happens if you build something, you test it, and then you probably run into some kind of limitations. The question is this a hard limit or is this a soft limit? So could we request a quota increase? I guess no, because it's the HTTP response. Probably has some kind of implementation implications on their side. Let's check it. So we could go back. We can other quotas, limits, quotas. There are no quotas or limits defined here. All API and references. Let's check there. No. Quota, limit. Nothing here. Let's use Google. Google Cloud Workflows, quotas, limits. All right, we're getting something. Where is it? Where is it listed? It's on a different page. Workflows. All right. Quotas and limits. So we had this above 2 megabyte for our quota. So you can increase or decrease these quotas. So those are adjustable. Those are the quotas. HTTP request. It's just calls, your number of calls, number of requests. I see it by the number on the right here. Nothing which fits to our limit or quota. So quota increase, yeah. And we have limits. You can't request changes to those limits. All right. What do we have here? Assignments per step. Also nothing related to us. Maximum steps, parallel steps. Don't use this. Resource limits. You can't request changes to these limits. All right, so this is probably where we are. Exactly, there we have it. Response size. So the maximum size of a HTTP response, if saved to variable, is if saved to variable. Yeah, we return it. So we need to store it somewhere if you want to do something with it. So we are limited to 2 megabyte. That's good to know. Kind of weird limitation. Why just 2? It's an HTTP request. Why not a little bit more, right? Yeah. If you want to do something, we're just using it as a return value, right? So it's already at a point in the application where even if we're doing something with it, we are still having this limit because it's the HTTP response limit. If saved to variable, then the memory limits apply. What are the memory limits? Memory limit, not mentioned. Maximum amount of memory that you can use for all variables together. All right. So we could anyway not store it in a variable. That's good to know. And the response is just 2 megabyte. All right. That's how it is. Need to find a different solution. At least we know how now we can use the HTTP post request, which we're probably going to use in the next step, because if we cannot use this directly with Cloud Workflows, like we have done here, which I actually like because it's quite easy to use, we still have the option to build a Cloud Run service, which uses, for example, the Python SDK. We generate the image inside of Cloud Run and call Cloud Run as part of our workflow step. And instead of returning the image, Cloud One stores it directly on cloud storage, and we just return the path where we actually store the image. But this could work. I'm quite a big fan of Cloud One. It's just where you can host serverless Dockerized applications. So you build your Docker application, and then you deploy to Cloud One, and Cloud One takes care of scaling up, scaling down, depending on the number of requests. It scales within a few milliseconds, can scale up to thousands of simultaneous requests. So at a very large scale, we could just simply build a small, maybe Flask application to actually do this as part of the Python code. Let's go here. Let's do this. Create a new folder, call those services. Not sure if you're getting more. Creating a folder, generate. Let's just call it image, right? We have image and we have recipe. So we have image and we have call it main.py for now. And let's take the let's take the sample code which we saw before. We had here this example. Let's take the Python example. Right, let's copy paste this. And here, because we want to have a Dockerized application, we're also creating a Docker file. We have requirements. Anyway, makes sense because we have a Python application. And I also want to build the Dockerized application with Cloud Build. I'm not a big fan of building locally, so I'm always building on the cloud. So we call this cloud build.yaml for actually deploying, so for building the image and for also pushing the image and also deploying the Cloud Run service. So we're doing everything with Cloud Build here. For now, let's have this here like this. Let's define the project ID. We have a prompt. Generate a hot dog. Actually, generate an image of a hot dog, right? We cannot generate hot dogs, but it's fine. Aspect ratio. What do we have? The 16:9, which we had before. Safety filter. We don't need humans on recipe images, so we remove this. Let's actually not remove it. Let's comment it out. Number of images. Let's just do one for now and see how this works. We have an output file. Call this. Oops, sorry. Call this. Yes. Because it's temporarily, right? We'll later on run this on Google Cloud on Cloud Run. So we anyway not store it to any kind of file system. It will be kept in memory. So we can just call it temp recipe for now. But what is it? What are we calling here? Are we calling images? It's the image generation response, and we have a save method. What is it doing? It's using pill image save. So it's a very common Python library for working with images. So we can just simply define the file ending, and it will encode it correctly. All right. That's probably all we need. It was already defined here. You see, I haven't seen it. That's fine. Okay, give this a try. So we have Python 3. Probably already have everything already installed. If you do this the first time, you need to install the Vertex AI SDK. I have this already installed. So you don't need to do this here. Python 3, and we call this in a different folder, right? So we see the services image, and now Python 3 main.py. Let's give this a try. See if we can actually get an image back. Open the text sometime. That's good. Create an output image. We're getting the bytes here again. So we see here, it is too large. Actually nice that they actually print this here in the sample code. Could have tested this before, and we could also check the limitations before, but I think we don't waste too much time for implementing the workflow step. That's fine. And we learned something about HTTP post requests as part of a workflow. I think that's okay. All right. Let me see where, yeah, there we have it in the file system. So we're getting a hot dog. All right. I also want to see how the output looks like if we are generating 4 images. And then we have images 0.save, and we could iterate over it. But it's actually easy, right? Let's take this one. Let's do it like this because I want to just could print. I want to see what's inside of images. Probably a huge print now. And let's give this a try. Want to see how they are encoded there, what we are getting back as part of these. We can actually have a look into. So it's image generation response. Could also assign this as a proper object, but we can do it later. Yeah, so it's generated image. All right, that's fine. And have a look into the documentation later on. So it's generating images. Now we need to put this into a proper Dockerized application. We need to also tell the model to tell this Dockerized Cloud Run service later on to deploy that, to store the image on cloud storage together with the same UUID. So later on, when we're going back to our recipe workflow, so we are generating our recipe here. And we are also generating this UUID. We probably need to do this as a variable at the very top. And then we can use the same UUID for the image. And later on, when we are calling, we have additional step here, which we call later on generate image. And it will be generate recipe image. And it will be calling our, so we have just this call, and then we have this HTTP post like we had before. But instead of calling the Imagine API, we are actually calling our Cloud Run service, which we're probably going to deploy in the next session. And from there, we're getting, as a response, we are getting probably the image back. We are passing as a body the args. Maybe some sample code here, right? We have a body, and we're passing the UUID here as well. For generating it on the Google Cloud Storage bucket. We're also passing the Google Cloud Storage bucket to the Cloud Run, so we have it all parameterized. And from there, we are returning probably an object later on here, where we have the recipe as a JSON. Could do some parsing encoding here as well. And we are also returning the path where the image is stored. And from there, we can take it to the next step and then put the human into the loop into action. So yeah, so we learned there are limitations on cloud workflows, around 2 megabyte. So if you work with larger returns, you need to put your whole logic into Cloud Run, because there you have a quite large limitation, which is limited by the number of memory you can have. As I said, there's no files storage for Cloud Run out of the box. And there we don't have any kind of limitations this way. And then we are calling Cloud Run from our cloud workflow. We could theoretically also put this into Cloud Run and have it as a little bit simpler here and use this as a Python code. I'm not quite sure if this is actually a nice way of doing that. It's nice that Google has those services where we can connect, but I think it's better if we next time maybe also build a Python service for that and simply call the Cloud Run services. And you get proper logging inside of the Cloud Run services. And yeah, that's what we're going to do next week, next Friday. Hope you had some fun and you enjoyed the session. As always, there's a little bit of struggle when you do something, but I think we figured quite a lot of things out. And yeah, we have a recipe, we're getting the image, and next week we're putting the whole picture together. So we have something where we can actually maybe build a website around it in a couple of weeks. All right, thanks for joining. See you hopefully next week. Also nice for your interaction here in the chat. If you have more ideas about topics, you can also ping me on LinkedIn, but I think with this one, we'll probably do it for the next 2 or maybe 2 or 3 weeks. I think in 2 weeks, we are probably already done. And then we can have another topic. All right, have a wonderful last day of the week, and see you next Friday. Thanks, bye-bye.